Hey everyone. So I know this is a little bit late, but one of the things that I need to go over with you is how do we actually use SPSS to do statistical analyses? And unfortunately, with the last video that I was making, I had ran into some technical issues, so I need to start the whole thing all over again. But anyway, everything's working out now, so I'm feeling a lot better about it. So I'm going to share my screen and I'm going to pretend like we are just starting at the very beginning. So essentially I've done nothing. You can kind of see what's going on here. When we're going to be using SPSS to do t-test analysis, or if we're going to be using SPSS for ANOVA, one of the things we have to do is learn how to prep our data for that. So the data that I'm going to give you is just this practice t-test in ANOVA, not a big deal. And just because of how SPSS does the things that SPSS does, if I want to perform a t-test, I need to come up with a couple different columns that SPSS is actually going to recognize. The way that the data is set up on this Excel sheet, so it's just a whole bunch of columns of data, SPSS does not like that, will not use that under any circumstances. End of discussion. I know. So we need to manipulate the data a little bit just to get it ready for doing these analyses. So let's say I want to analyze the data that I have for, say, Med A versus Med E. One of the things I need to do is create a new column. I'm going to call it Med, and then because I'm going to be comparing groups A and E, type those out on there. I'm going to have another column in here that I'm just going to call result. So nothing too big and scary yet. Now here's where it gets weird. In order to analyze the data using a t-test or something like it, I have to go in here and I have to come up and I have to copy all of my data that I have under medication A, come over here to result, and just paste it. So hopefully most of you have used Excel in the past and you know how to do this already. Now, the column that I've got here where it says Med AE, this is where, or we can think of this as, say, an identifier column. This is going to show us what data in result belongs to which group. Unfortunately, the way that SPSS enjoys this, all these values have to be numbers. So I literally have to go in here and type in 0 for all of these. Ugh, I know. For medication E, come over here. I need to copy and paste, and then just do 1, 1, 1, 1, 1, 1, 1. And now what I need to remember is that in this indicator column that says Med AE, I have either zeros or ones. So it's nothing too drastic or anything like that. And all I did for the result column is just copy and paste whatever I had over here. Now that I've got the data set up the way that I do, I can come in here and cancel that out. And I want to save that data, so yes. Now I get to go to my version of a SPSS. And one of the technical issues I had previously was my license expired. So when I went to open this, it went to the you need to renew your license thing. And dear God. But anyway, we now have what we have here. Everything that I have in this recent files thing, this is all data that I've used before. Yours is going to be completely blank, okay? So, and because I want to use data that is not in here, there's this thing up at the top that says new data set. So I'm going to go ahead and put my mouse on that. And then I can either come down here and click on open, or I can double click. And what we've got here, no, I'm not going to help you improve right now. Get off my screen. So what we've got here is what SPSS calls the data editor. This is where we import the data. So now that I've got it at this point, I can go to File, and I can import data. The data that I'm going to import is from Excel. Now you can see all these different things on here. But this is from my file folder called stats data. That's not where my data is at. So now I get to manipulate this, bring it up to desktop. Then practice t-test and ANOVA. That is the file that I want. My suggestion to all of you is when you import your data, you save it on the desktop. Or if you're going to be doing research with a professor somewhere, you can create a folder where you can store all of your data sets like this. Now that I've clicked on practice t-test and ANOVA, I'm going to go ahead and click on open. This whole new thing pops open, and what I need to do is make sure that everything that I had in the other data set has actually popped up here. And it does look like everything is where it should be. So I'm going to go ahead and click on OK. And a brand new data editor just popped in, and you can see it looks a lot like an Excel sheet. Some funny stuff happening on the top of it, but whatever. And I've got my column for medication AE. I've also got my column for results. One thing that you're going to notice with SPSS is versus the Excel file that I had med space A, med space B, med space C, and so on. SPSS doesn't like having spaces and names, so it deleted all of them automatically. Now that I've got the data that I want, now I can go and try to do the statistical analyses that I need to. Going to be honest, there's going to be quite a bit of button clicking, so if you can get this video up on one side of the screen and then have a SPSS up on the other side of the screen, it's going to make it a lot easier for you. So I'll give you a second for that. Once you've got that set up, we can come up here, come up to where it says Analyze on the top. And I apologize, I do not know how to make these fonts bigger. So if you do have some visual issues, I'll try to walk you through everything here step by step, so you don't have to, so you can kind of listen. But I'm going to go to Analyze on the top ribbon. And then I've got all of these different things that just popped up. There's a thing here that says Compare Means and Proportions. So I want to use one of those. The next thing that I want to do is if I've got two different samples, so I'm looking at medication A versus medication E, this is going to be an independent samples t-test, which I've got highlighted right now. Once I've done that, I can click on OK. This new thing is going to come up at the top here where it says test variable and then variables. That's the results that we want. So you can barely see it on here, but you can see down here where it says results. I'm just going to knock that over. Now the grouping variable, this is where it gets weird. If we were using a lot of other software, any column or any two columns I want to compare, I could actually just click on those columns and it would do it. But the grouping variable, this is going to be that med AE thing that I've got. Once I've brought that in, I have to come in here and I have to define groups. And group 1, I labeled as 0. Group 2, I labeled as 1. So I need to change those things over. Once I've done that, I can then click on Continue. And looking at everything else that's on here, there is a test here for homogeneity of variance test. I do want to use that. If I come up here to where it says options, this is just giving me an idea about the confidence intervals that I want to deal with. And we're dealing with a 95% confidence interval, so I can go ahead and click on here and click on continue. Once I've got all of that set, I can now come down here and click on OK. And what's going to happen is when we hit the OK button, it's going to do the statistical analyses and bring up yet another window. So the window that we've got right here, and again, I do not know how to change the font on here. So again, I am sorry about this. But this is called the statistics viewer window. This is where all the results are going to be happening. And looking at the independent samples test and looking at the homogeneity of variance test, this is trying to help me determine which type of statistical or which type of t-test I should be using. Looking at the significance, that's right down here, it's coming at 0.949. That is well above 0.5. So that's telling me that the variance between medication A and medication E is essentially the same thing. So now that I've got that test, I can actually come up here and look at a result for equal variances assumed. I have my t-value, I have my degrees of freedom, and the p-value for a one-sided and a two-sided test. So what's actually going on here is it's already decided to do a one-sided test. So if we're interested in is one group bigger than the other, we can look at that. It's also doing the standard two-sided test. And if you notice, the two-sided p-value is about double what the one-sided p-value is. And that's because of how all these things are set up. Now, with the one-sided test, the way that we were talking about them in classes, we might be looking at, say, is medication E bigger on average than medication A? Because we're looking at, say, trying to come up with a better medication to use for our patients, something like that. Well, this is always going to just take the one-sided p-value and cut it in half. So if you put in the analysis the wrong way, and let's say medication A is greater than medication E, but you're interested in testing is medication E greater than A, that one-sided p-test, or the one-sided test there, will probably or could give you a statistically significant difference, but it's not necessarily testing the thing that you are interested in testing. I know, annoying, but it happens. So looking at the rest of the data that I've got here, we have the average difference between these two groups, the standard error for the difference, and then we've got the upper and lower confidence interval for the difference between the two groups. So just looking at this really quickly, and again, it's really small fonts. Sorry about this. I don't know how to make it look bigger, but it's going from negative 8.57 to 9.93. Since it's going from a negative value to a positive value, that's telling us that the confidence interval contains 0. And because it's going from negative sign to a positive sign, we really can't tell if one of these things is, say, better than the other or different from the other. There's a lot of other stuff that pops up down here, which we may or may not, you may or may not need for this class. We don't need to worry about any of that. So just going with what we've got here is completely fine. And one of the things that happens as well is if we look over here, it gives us the result for 0 and 1. Well, we know that medication 0 is actually medication A. We know that medication 1 is actually medication E, but the software doesn't know that. So it just prints it out as a 0 and a 1. Something we can do to help us kind of remind ourselves of what all these things are is if I go back to the data editor, so the thing that's got all of our data on it, and I click on where it says variable view. Now I can come up here where it says none, and I can actually put in some new values here. Uh, there's the green cross with the white background. So if I click on that, my numeric value is 0, and I'm going to call that, we can just call it med A and leave it with a space in there. Not going to be a big deal. Going to come back up here, click on that again. Going to say that my value 1 is now med B. This isn't really something that you need to do. It's just something that can help you out if you're going to be, say, printing or presenting data like this. Having everything set up properly or having these names show up would be nice. And that should have been medication E instead of medication B. But anyway, I've now got it labeled, so I can now click on OK. Now, if I do that analysis over again, so if I go to Analyze, Compare Means and Proportions, Independent Samples t-test, everything is ready for me. All I need to do is click on OK. And when we scroll down, you can now see that's 0 and 1. So this is what it looked like previously. This is what it looks like now, and it says Med A versus Med E. Everything is going to be basically the same. It's just that it's going to actually tell me what it is I'm looking for. Okay. Now, let's say, now that I've got all this stuff set up, I'm going to minimize a couple of these. This is an old data editor that I don't need. So going back to where we change those variables, I can change the back to data view so we can see everything that I've got here. Now let's say we're interested in testing, is there a difference between medication, say E, and medication F? Initially, I made these changes in Excel and then saved it and brought it in here. Sometimes that works out fine, sometimes not so much. If I do need to create new variables in here, I can actually come up here and it flips me back to a variable view. So here, I'm going to create a new column that says med EF. The values that are going to be in here, oops, like I said, uh, so like I said, SPSS does not like having spaces in their variable names. SPSS just needs to freaking grow up, okay? So med EF, going to leave it as is. I can come up here again to names, and I'm going to type in, so again, I'm going to say value of 0. This time it's going to be medication E. One more value in here, it's going to be 1. This is going to be medication F. If this is a little bit much for you, don't worry. You can go back to copying and pasting in Microsoft Excel. This is just something that if you are using SPSS, sometimes the people you're working with are going to expect you to be able to do what it is we're doing here. Oops, I also need, um, I'm going to create a new column results for our ENF test. Go back to data view. Now we get to do the same thing over again. Everywhere, I'm just going to have 10 data points that are medication E. Again, 10 data points that are going to be medication F. So this is exactly the same thing that we were doing in Microsoft Excel. So blah, blah, blah. Now when I need E, I can come over here, copy it, and then come over here and just paste it. And then I want to look at F, so I can come over here and copy it, and come over here and paste it. And now we're ready to perform another t-test with the data that we have here. So with this new data, if I want to see, is there a difference between medication E and medication F? I now have to go back to Analyze, to compare means and proportions, then come down here to where it says Independent Samples t-test. Click on that. This new thing is going to pop up, or the same window is going to pop up, but I need to remove the old data that I'm not going to use anymore. So my test variable is now going to be results EF. My grouping variable is going to be med EF. I have to come back in and define groups. 0 is medication E, 1 is medication F. I can click on continue. Still want to perform that homogeneity of variance test. I still want to estimate effect sizes. So now that I've done this, I can go ahead and click on OK. And we now have our new analyses looking at medication E versus medication F. Looking down here, says results of E and F, homogeneity of variance test. Looking at the statistical significance here, it's at 0.09, so 9% roughly. Because we only have 20 data points that we're dealing with here, it's usually a better idea to use different levels of statistical significance with different numbers or with different amounts of samples that we're dealing with. In general, 20 data points like we've got here, I would actually be using a 90% confidence interval and 90% statistical significance and all that sort of stuff. So when I'm looking at the significance of the homogeneity test, I would actually be concerned that the variances are not equal. And with the data that we're using here, it's stuff that I actually made, and I purposefully made medication F have a very different variance than everything else. Just because of a random number selection and stuff like that, that we get these different results here. So once we're looking at the results of this particular test, we can say equal variances not assumed, and we can look at the values that are actually down here on the bottom. And again, this is telling us that there does not seem to be a statistically significant difference between the two groups. Up here, we can see that medication E has an average of 26.2, medication F has an average of 26.8. Because these standard deviations and because these standard errors are so large compared to the difference between these two, we're not going to find any difference. Now, if we had Instead of 10 people in each group, let's say we had 1,000 people in each group and these numbers were the same. At that point, we might actually find that there is a statistically significant difference between them. But for right now, with the values that we have, I'm going to say no. But because of this variance test, because it's below zero point 0.1 and zero point 0.1 based on the data we have. If I had 50 people in each group, I'd go 0.95. If I had 300 people in each group, I'd probably go 0.99, just so we have an idea about my personal preferences. So equal variance not assumed. We're going to use the information that's on the bottom here and go with that. And we can see that there doesn't seem to be a statistically significant difference between these groups either. Now, one of the other things that we can do with the data the way that we have it is we might be violating one of the other assumptions we have for the t-test, which is that the data are normally distributed. Nothing that we have done gives us any indication if whether or not the data is normally distributed. So I'm going to come up here to analyze. And if we come down here, there's something called non-parametric tests. And I want to do independent samples. So the non-parametric test and independent samples, can click on that. And what it's automatically going to do automatically is, so you can see here, it says automatically compare distributions across groups. We may or may not actually care about that. The two sample t-test that we did is looking at is the mean or is the average of one group different from the other. For non-parametric methods, comparing medians would be similar to what we did. So I'm going to come and click on compare. I now have to go up to fields. And the test fields here is going to be the results that I want to look at. So if I want to look at results of E and F, I can go and click on that. And then the groups down here is going to be Med EF, which is what we had before. Now I can come up here to settings. I can make it so that it automatically chooses the best test based on what we have. Mann-Whitney or Kruskal-Wallis are going to give us essentially the same thing. We've got a lot of these other things that we can test. So it's already chosen the medians test. I can choose Mann-Whitney and Kruskal-Wallis, and we should end up with essentially the same thing. Now I'm going to come down here and hit run. And we now have our results here. So one of the nice things looking at this, it says the median results of ENF are the same across categories. So that's a test that we did. So the independent samples median, and it says retain the null hypothesis. So it's already telling us whether or not we reject the null hypothesis. It's just saying, no, fail to reject. With the Mann-Whitney, so the distribution of ENF is the same across both. This is saying retain the null hypothesis, which means it doesn't think that the distributions are different from each other. And then for this last one, it's looking at the same question, and it's telling us again, there doesn't seem to be a difference between the distributions. So it means that they both seem to be the same thing. And basically with everything that we just looked at there, it's telling us that there doesn't seem to be a statistically significant difference between the groups we looked at. We can come up here and look at the box plots of the two different groups. You can see that the medians and the means are really, really close to each other. Well, we already knew that. This is a little bit of a rank test, I believe. And again, it's showing us that there doesn't seem to be a difference between the groups. And then there's a lot of other stuff that's going to pop up here. So blah, 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 blah. I didn't give any of you any formulas for how to do these tests because one, I don't remember the test to begin with, or the formulas for the test to begin with, and two, some of these can be really, really difficult to do if you're going to try to do it by hand. You can't even do these tests with a calculator, but at least with the data that we have here, this is how we would do it. And rather than like give you a test on parametric and non-parametric methods and blah, 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 I'm just going to say that there are other options if your data does not conform to the assumptions you had. And we can use, again, when you go to analyze these non-parametric tests, you will have to look them up to make sure that it's doing the type of test that you actually are interested in and that you actually care about. Once you've done that, you should be good to go. Um, but this non-parametric stuff, it's not going to be something that's on the test. It's just going to be something that when you're in the test of life, I guess you could think of it, you may need to use some of those methods. So all that you really need to know how to do here, how do you do a t-test with a couple of different data points? So at that point, I'm going to stop this recording. And if you have any questions about it, feel free to ask before class or after class, or if you want to do a personal video like this, totally fine with that too. And I'll look forward to torturing you guys later.